This spreadsheet exercise compiles a list of your household items. It notes their power requirements, how to work them out, and then adds calculations step by step to show how each item contributes to your daily electricity consumed in the home. Start by going around your house to list 2 columns of electrical appliances and devices in each room. This is in column A. I suggest start with a few items in column B to familiarise the assembling of the sheet, as more can be added later. Family members of school age and above can do this together. Add 2 more columns, C and D, to enter the maximum rated power in watts found on the serial plate in column C, and in column D the actual watts, which could be a repeat of C or more likely a lower estimated value for items with controls that do not use full rated power all the time. It is this estimate which is important and needs to be used in your subsequent calculations. Items such as fridges, 60%, irons, as little as 15%, washing machines, about 40%, all vary their power during operation. My estimates in brackets are to get you started. The next few slides explain this more fully. This first example shows what happens when you turn a light bulb on, for example. It runs at constant power for a certain time. Other examples would be a kettle, which runs at its full power for just a few minutes as you boil the water, and then it turns itself off. The graph on the right shows that the energy of the light bulb that's consumed in the time you've had it on is proportional to the area under the graph. Now let's look at an item that is turned on by a thermostatic control, such as an iron or a coffee machine, and I'm sure you can think of other examples that turn on and off. By timing the amount of time the red light is on an iron, for example, you may find that it's only consuming about 15% of the energy it would have done if it was using its maximum rating all the time. A more complex example is that of a washing machine or a dishwasher that carries out several different functions during its cycle. Most probably, the highest power is used when it's heating. But here you see a washing machine is also filling, it's swilling and emptying, it spins and it refills, and it repeats that cycle several times. So there are spaces where less energy than the maximum are actually being used, and the area is as shown in the blue diagram. Add a column E for notes, and then 3 more columns F, G and H for your estimated daytime, evening and overnight use in hours of these various appliances. Always convert any entries of minutes into decimal hours, minutes divided by 60. These periods relate to your own lifestyle. When you don't have lights on during the day, for example, evening when perhaps you do more different things, and overnight when you're in bed and probably nothing is running other than a fridge freezer and maybe 1 or 2 timers. Then add a 4th column that totals F plus G plus H into total daily hours of use. Be aware that this total cannot be more than 24 hours in one day. That completes your input section, basically. The next slide set up calculations to assess your daily energy use. Before we go on, we need to note that an item that runs only a few times per week will need only a proportion of its hours entered that reflect its equivalent daily use. For example, a dishwasher, if operated 4 times each week for 1.8 hours cycle, would have a daily time of 4/7 of its operating time, that is 1.03 hours each day, which needs to be entered in one of the 3 hours columns for daylight, evening or night, depending on when it's run. Add 3 more columns, J, K and L, to the right of the sheet that will calculate in their respective cells the daily energy in watt-hours for each appliance in each daily period of daylight, evening and night time according to your daily habits. Each energy cell is a product of the item's estimated power in watts multiplied by its estimated use time in hours in each relevant period. Then add another column M that adds J plus K plus L to give the total energy of each appliance for the whole 24-hour day. An item like a fridge freezer will be running all 24 hours. That total cannot, of course, be any more than 24 hours. And having grasped that, now add all your remaining items to complete this stage of the spreadsheet. Now add a row at the bottom of the energy columns J, K, L and M for each period that sums the columns to calculate the total household energy consumption during each period of daytime, evening and nighttime, and the total 24-hour day. Then add a row under these daily totals that calculates the monthly totals in kilowatt hours, kWh. These are the units we pay our utility suppliers for by our tariffs of pence per kilowatt hour. Remember that your calculated monthly estimates will be an average, because your actual monthly bills will vary through the seasons according to the amount of light, heat from electric and other activities that you use during the different periods. Your spreadsheet bottom lines should now look like this. You're nearly there. Add a cell under the monthly cells that calculates your total annual energy, the energy per year in kilowatt hours. Remember that your calculated monthly estimates are an average. The actual monthly bill will vary through the seasons. Your completed spreadsheet should now look like this. Now find from your previous bills 2 that are 12 months apart. That will give you your annual energy consumption in kilowatt hours you were charged for. These need to be actual kilowatt hour readings if possible, not estimates by your supplier. Subtract one reading from the other to find out what your actual annual consumption in kilowatt hours has actually been, and then divide that by 12 to find your actual average monthly consumption. Now go back to your spreadsheet and check whether your annual kilowatt hours total estimate is higher or lower than the actuals that you've checked on your bills. You can now go through your watts figures you entered in column D and your hours figures entered in column F, G and H to make some adjustments to some of your estimates until your totals from the estimates are within a few percent of those from your actual bills. As a tip, I would focus on the most variable items. When you're content with your result, you should now have a fair audit of your home electricity, item by item. You are now able to add a new column N, which calculates and shows the percentage that each item contributes to your total. From this column, you can identify items that most affect your resulting consumption and its costs. Column N cells are the daily watt-hours of energy of each item in column M, divided by the total of column M, expressed as a percentage. You are now able to add a further new column O, which calculates and shows the cost of each item according to your own tariff. This column is the daily watt-hours of the item from column M, divided by 1,000 to convert it into kilowatt hours, and then multiplied by your tariff in pence per kilowatt hour to give its cost. For example, a fridge freezer consuming 1680 watt-hours per day is costing 74p per day on a 40p per kilowatt hour unit tariff. And that is it, completed. You now have a spreadsheet that illustrates your lifestyle of electricity use, the percentage that each item takes of a total, the costs of each item, and the totals to compare with your actual bills. Thank you for watching, and good luck with your energy savings.